All right. So hopefully everyone can hear me. My name is Christian Putlitz. I'm the department head of mechanical engineering here at CSU. I've been at CSU for about 15 years in mechanical engineering. I'm also a professor in biomedical engineering. I know some of you may be interested in the dual degree program that we have. Because of the research that I do, I also have an appointment in clinical sciences over at the veterinary hospital. So I don't know if many of you have been to Fort Collins. Probably many of you have. It's a fantastic place to live. It's been recognized by too many magazines with too many people moving here, but it's still an incredible place to live. If I had to do it all over again, I probably would have come here for college. It's just the balance of the university and living outdoors in the town. It's just a really, really cool place to go to school. So I encourage you to come visit. I know it's a little tough with COVID and everything right now, but it's really, really been a fantastic place for me to be a professor and to teach in this department. It does get over 300 sunny days a year, which is an added bonus. The university this is the main university for the college CSU system. There's a little over 34,000 students right now. About a little over 24,000 of those are undergraduates. We have about 1,900 faculty and another 7,600 employees. So it's a really big place. But mechanical engineering, I think, is a really nice, intimate department, even though it's rather large itself. It is a big research university, and you can actually take advantage of that with the opportunity to get involved in research, and I'll talk a little bit about that. The university is celebrating its 150th anniversary this year. It was originally the Agricultural College of Colorado, and in 1935, it changed its name to Colorado State College of Agriculture and Mechanical Arts. So you can see mechanical engineering has been a vital part of this university since its beginning. And then in 1957, it changed its name to CSU. What is mechanical engineering? It's a pretty broad topic, a pretty broad area, but it's essentially applying advanced mathematics and sciences for analysis, design, manufacture, and maintenance of mechanical systems. And these mechanical systems are really, again, very widely varying. So I work in biomedical engineering, so I do 3D printing of tissue. I'll talk a little bit about that in a little bit. And what can you do with a mechanical engineering degree from CSU? The short answer is you can do pretty much anything that you want. And the first three bullets that I've shown, air quality, energy and environment, and biomedical, aren't typically three things that you would think of that you could do with a mechanical engineering degree. The last bullet also is finance. We provide our students with the ability to do very, very deep analytical thinking and analyses, and that's very much valued by the finance industry. So we've had a number of our students either go on to get an MBA or get directly hired into finance companies. We also have a pretty big aerospace and aeronautics group, and I'll talk about that. We just started an aerospace program that you can take advantage of if you came to CSU. And then some of the more traditional things that you think about in mechanical engineering: automotive and transportation, manufacturing and industry, and robotics and controls. We're involved heavily in all three of those areas. What about mechanical engineering at CSU? So on the right is kind of a spaghetti map of the courses that you would take in order to get your degree here at CSU. It looks really confounded, but it's kind of broken into different areas, and this is where the advising team really helps you figure all that out.
Sorry, Christian, I can't see your screen. Can anyone else see? Can everyone else see a screen? Okay, I'm seeing. Maybe try sharing your screen one more time.
Oh, let's try this again. Can you see that?
Yep, now it's working.
Okay. Okay, can you see that? Okay, perfect. How do I know that we deliver a world-class mechanical engineering education? Because before I came here, I was at the University of California. I had an appointment in San Francisco and Berkeley. And many people consider the University of California at Berkeley Mechanical Engineering Department to be the #1 mechanical engineering department in the United States. And I can guarantee you that the education that we will deliver to you is going to be as good, if not better, than you would get at Berkeley. We're one of the largest undergrad programs at CSU. That should actually say 950 students, not 450. We have very excellent students. So even though we have this huge, very large student base, we have excellent students. The average incoming high school GPA is about 3.9. Our undergraduate mechanical engineering courses are taught by full-time faculty. We do not generally have PhD students or graduate students teaching you. You are taught by people who have PhDs and are experienced in the field and experts in these fields. We increased the number of faculty. We added 5 faculty last year. So now no course in mechanical engineering has more than 85 students. Okay, so you're going to get smaller class sizes than you would typically get at other universities in a mechanical engineering department. Many of our students do internships and co-ops and lab work. I'll talk about the lab work in a little bit, but internships and co-ops, we try to value those. That's great experience for our students and very often leads to jobs after they graduate. Our students work hard, there's no doubt about it. This is a very difficult major. One of the most difficult at the university. But if you make it through our program, your starting salary with a bachelor's degree averages about $70,000. We have some students who go and start over $100,000 with our degree. So this is a highly valuable degree, and even though it's very difficult, it pays off in the end. And we have our undergraduates solving real problems. We're just not letting them sit in a classroom and absorb a bunch of mathematics or other equations. We actually have them in our research labs working on real world problems. They're designing and building hybrid electric vehicle systems. They're working on solar cells. We have a number of them who go to third world countries and implement different technologies such as biofuel stoves. We have them redesigning incubators for ambulant transports for neonates or very young babies. I underline designing artificial joints and tissues for the human body. That's what I do in our laboratory. And we have them also working on reducing emissions. Our goals are to prepare our students to be highly productive engineers from the day they begin their career. We do this, we very much value the hands-on experience in real world situations. Now, obviously with COVID, the hands-on experience has been compromised. We are still having our students in our labs now. We just offer a lot more sections of them so that there's less students in our labs. We provide a thorough grounding in mathematics and science and the engineering sciences. We focus on the program on our senior design capstone course. So those in the last year, you take your senior design, you actually get in a team of 4 to 8 students and you work on a project. And we provide opportunities to be involved and impact our world. That's very important to us, that we don't just have our students doing a bunch of book work, that they're actually impacting our society. So what does it look like? So the first year you're transitioning from high school, you're taking some of the basic courses such as calculus, physics, and chemistry. A lot of you will already come in with some of those credits. In the first year, we offer 2 mechanical engineering courses, 1 each semester, which focuses on engineering practice, as well as teaching you computing skills such as MATLAB that you're going to use for the rest of your stay at CSU. In the second year, we start to introduce you to some of the engineering sciences, such as statics, and dynamics, which are engineering mechanics courses. And then also engineering practice, such as computer-aided design, manufacturing, and engineering design as well. So this is one of our sophomore level engineering design courses. And at the end of every semester, we have a competition. So there's a design competition. And let me just show you. So in this competition that I'll show you here on the right, essentially you'll see these 2 cars, and the competition was who could smash the other's car off the table and design it so that it provided that type of leverage. So that's a pretty fun event that I like to go to. You can see how many students actually show up for that because they're really interested in seeing what the students come up with. So it's a really fun event. The junior year, we really start to get very heavy into the advanced engineering sciences. We look at things like material science. We also look at computational fluids, which is the lower left image, and then also computational solids, which is the beam that's bending right here. We also do mechatronics, how to put electronics and drive mechanical systems. And then also thermodynamics as well. So this is a very heavy year in very important engineering concepts. And then the final year, the senior year, we focus on this senior design practicum. So here are some images on the right. We're involved in the NASA mining competition. So every year we design a robot that NASA will use or is trying to use when they land on places like Mars. To start mining to mine Mars and take samples back. On the right was a dog amputee, and the students designed a prosthetic for that dog. On the lower right is a woman who became paralyzed. She wanted to be able to go off-road with her wheelchair, and so they designed hand controls for her. So that was their senior design project. And then the image next to it is a purge system for a brewery. So we typically have 20 to 30 different projects every year for our students to choose from and get involved in. And then also the senior year, you also then get to start to choose some of the courses that you want to take that are in your own personal interest, such as pollution, if you're interested in bioengineering, space propulsion, biomechanics, vibrations, etc. So you get to choose those 4 courses, and those are the technical electives that you have control over. And speaking of that, so we started an aerospace engineering program. So when you get to your senior year, you can actually get involved in this undergraduate concentration. Essentially, it's 4 technical electives. You can pick, I'll show you the courses that you can pick from. And actually then it shows up on your degree. So you get a mechanical engineering degree with a concentration in aerospace engineering. These are our course offerings in aerospace. So you can see they're quite broad in fluid flow, propulsion, structures, and materials and manufacturing. So you can take any of these courses that you want in order to satisfy your aerospace engineering concentration. So this is a new program, and it's been very popular amongst our students. So that's kind of the curricular side. And then what's also important is that you have support. And that's where our advising team comes in. So Matt Markham is on this call. He's one of our advisors. Our advising team is led by Tony Lee Viney, who's been in mechanical engineering for quite a long time. And then our other 2 advisors are Star Sullivan and Angelica Hernandez. They'll assist you in completing your degree program. They'll put your schedule together depending on what your timeline is for when you want to try to graduate. But they're here just not to put your schedule together. They're here to provide you some support. So they can show you what campus and community services are available if you're having a hard time or if you need support in a particular area. They can provide opportunities for professional development as well as some social events. And essentially, they're here really to celebrate your success, right? We all try to celebrate and support your success. And I love this quote at the bottom of this slide, which is, "Good advising may be the single most underestimated characteristic of a successful college experience." I'm so proud of the advising team that we have because they really, really do promote success, and their advising really becomes important. If you talk to our students, they'll talk about the importance of advising. People don't typically think about that when they're trying to figure out which department or which college to go to, but it's really important that you have that support network within the department that you're working in, and we have really a fantastic team. We also have a number of different groups where you can become involved. We also have a group called MESA, which is Mechanical Engineering Student Ambassadors. They're really here to support your transition into the department, whether you're coming in as a first-year student or a transfer student, and they actually help you make connections within the department. They also provide curricular support, so they have a bunch of tutoring, so you can see all the courses, so all those math courses or calculus, and differential equations. They also provide tutoring for every single one of our mechanical engineering courses, 1 through 300 level, physics, chemistry, and then Civi. These are the mechanics courses that you would typically take in your sophomore and junior year. So they provide a really, really nice support group. They put on, we actually give them some resources, some funding, so they can put on some events, so you can get to meet other students in the department. And they also help support a lot of these other groups. So on the right, you can see these are all different engineering related student groups that you can become involved in. This is a big one, ASME, American Society of Mechanical Engineers. This is a big group within our department, really important. And then Biomedical Engineering Society, if you're doing the dual degree program, is also a really big group as well. So I want to talk a little bit. So everyone kind of talks about, okay, what courses am I going to take and everything like that. And that's all very important. But what's also important is we try to get our students to work in the research labs because it provides them an opportunity to apply what they've been learning in the classroom, and really gives them, drives them to work harder in the classroom because it gives meaning to what they're learning instead of just doing a bunch of problem sets. So I want to talk to you about a project that involved 2 undergraduates in talking about printing regenerative scaffolds in my laboratory. So this is the spine. You can see the spine down here. I don't know if you can see my cursor. Matt, can you see my cursor at all? Okay, good. Excellent. So this is your spine, right? And then this is so you have a vertebra, and then you have a disc, and then you have a vertebra. And what happens is people get a herniation. So your disc actually, the tissue actually fails, and all of this tissue on the inside actually starts to squirt out. And this is your spinal cord right here. So it puts pressure on your spinal cord. And this is really common. Everyone knows somebody who's had a back problem, right? We started using 3D printing to try to fix this herniation issue. So these are different types of structures that we've been able to make with 3D printing. And it actually, this is this disc. If you look at it, it's this laminate situation. So you have a bunch of fibers that are sitting within a matrix, and you can see that we can actually recreate this structure using 3D printing. And so that's what we're trying to do. So we created all these different types of structures, and I had a graduate student, Mitchell Page, start to do a bunch of computational analyses. In other words, he's making these computer models to try to figure out whether it was going to be strong enough and stiff enough to put in the spine. But then I had an undergraduate, Kenzie Bairn, who actually started printing these things and started doing mechanical tests to see if we could come up with the same properties that the native spine has. So this is an undergraduate, a student who was sitting in your shoes 2 years ago, who is now doing 3D printing to try to reconstruct the spine. We did a bunch of cellular level modeling. So this kind of modeling then tells you whether if we put cells in there, if they're going to try to, because if they have the right loads on them, if they're going to reconstruct the right type of tissue. And so this is kind of these fibers that I showed you before. And all of this pink is new tissue that's being laid down by the cells that sit within this matrix. So, we were able to start kind of regenerating the spine based upon the structures that we were building with 3D printing. And so this is kind of some of the early 3D printing that we performed, right? So this would be a piece that would replace that failed piece of disc tissue that I showed you a minute ago. And what's really important is that these fibers are pretty large. So they're much larger than the size of a cell. And so we started doing a bunch of testing. So this is the dotted line is kind of what the design target is. This is what your actual disc in your spine, this is the type of stiffness that it has. And you can see we started creating structures that very much approach this type of stiffness. But we needed to have smaller fibers. So we came up with a new technique called melt electrowriting. And this was an undergraduate built this system in my laboratory. And you can see here that these fibers are now on the size of about 20 microns, or 20 times 10 to the minus 6 meters. And that's the same size as a cell that would be in your disc. So now we can actually engineer the local mechanical environment for these cells to recreate the disc in your spine. But this is all because an undergraduate built this system so that we could create these new fibers. So I just wanted to bring that out because, you know, you probably go to a lot of these talks and they talk about, well, this is what we have in our department, and, you know, these are the courses that we have, and these are the opportunities. But this is real life situation where undergraduates are making an impact on our research program and our ability to recreate and replace damaged intervertebral disc. I know a lot of people know people who have back pain. This is one of the leading causes of back pain. And so this is their opportunity to have an impact on a large segment of the population. So I just want to bring that out. Hopefully I didn't go too long. And I want to provide an opportunity for you to ask any questions that you might have of me. So thank you very much for your attention. All right.
Really quick, as you're thinking of questions, I am going to put some files in the chat. If you signed up before, I think you received them via email, but want to make sure if you didn't, that you have access to those. But otherwise, you should be able to unmute yourself and ask a question, or you can throw it in the chat if you prefer, and we can ask it that way.
How many freshmen are admitted in mechanical engineering? So we admit, let's see, I have to look at the admission numbers, but typically, I can tell you how many typically become enrolled. So we typically have about 220 students become enrolled in the department, and we probably admit double that. So we probably admit about 450 students into our department, and about half of those end up coming to CSU. How would the fibers be inserted into the spine, and how would they bend with the tissue of the disc? Very, very good question. So essentially what we do is we create those fibers, and then we put a gel that holds the cells in between those fibers. And then actually we 3D print a plate that actually is part of it, and the whole thing gets inserted, and then we put screws through the plate into the vertebra on the top and the bottom. So that's one way we're thinking about how we attach this disc. Another way is they have bioadhesives, right? So people, I don't know if you've seen this, you know, when people get a cut, sometimes they put like, you know, cyanoacrylate glue or Bondo on, or super glue on the cut, and it'll hold it closed. It's kind of the same thing. You can kind of put that glue in, and the glue actually is bioresorbable. So we're looking at different attachment methods in the spine, but we do it through a very small incision. So we don't actually even open up the whole spine. We do it through a small incision, and we 3D print a bunch of different instruments that allow us to place the implant or the scaffold where we want it to go. Good question, Ben, thanks. Are most students at CSU from Colorado? Yes, most of our students at CSU are from Colorado. I think I'd want to say probably 2/3 of our students are from Colorado. I'd have to go look at that to find out, but it's definitely the majority of our students are from Colorado. The great majority of our students are from Colorado. What does the mechanical engineering program look like if I have an AS degree? So if you have an associate's degree, we actually have a pathway program that I can tell you a little bit more about. We're actually developing a lot of relationships right now with a bunch of community colleges around the state of Colorado so that they can transfer more easily and readily into our program. But if you have an associate's degree, we can look at your the courses that you've taken and do a transfer analysis and let you know exactly which one of those courses would transfer. let's see, is there a specific aerospace engineering degree, or is the mech engineering degree with aerospace concentration the extent of it? Yeah, so right now, what we offer is a mechanical engineering degree with an aerospace concentration. And the reason why we do that, and there's, you know, in the future, we may develop an aerospace engineering degree, but here are the big aerospace companies in Colorado, and you probably know this already, right? There's Lockheed Martin, there's Ball, there's Northrop Grumman, there's Boeing. All of these people are on my advisory board, mechanical engineering advisory board. And what I've heard from these leaders in aerospace is that very often they would rather hire somebody with a mechanical engineering degree who knows something about aerospace rather than somebody who has an aerospace degree, because that degree tends to be more broad and not as deep. And so I know CU has a very good aerospace program, but we are different in that we are focused on you becoming a mechanical engineer and then also having some aerospace background, which makes you then very attractive to being hired by these aerospace programs. And by the way, many of you probably heard about the Space Force, right? And I know you've probably all seen the Netflix show, which is quite funny with Steve Carell. The commander of the Space Force, right, is an alum of our department. So he has a mechanical engineering degree from CSU. Let's see, can I double major in design and engineering? That's kind of interesting. Probably. I don't know, Ben, what kind of design you're talking about. We have a design and merchandising department, which is not part of engineering. We also have the Richardson Design Center, which involves some engineering faculty, but is still based in outside of engineering. But you can probably create a double major within design and engineering, yes. What kind of classes elective does CSU have that focus on building and or working with engines? So if you go to our website, you can see the list of technical electives, and maybe Matt can kind of put that list. Oh, I think he just put it in there. Well done, Matt. So click on that and you can see all the technical electives. We have a very, very big engines group. So if you look on our website, look up Dan Olson, one of our professors. He works in engines. Brett Wyndham works with engines. Look up those two dudes. They do a lot of work, and they have a lot of undergraduates working directly with engines in their labs. Do we learn about biomedical and mechanical engineering, or is that part of the dual degree? It's mostly part of the dual degree, but a lot of us who are involved in biomedical engineering teach the basic courses in mechanical engineering. So I used to teach Mechanical Engineering 325, which is machine design. And there's a really famous quote by Leo Tolstoy, which is, our bodies are machines for living, right? So I used to bring out a lot of what we were learning in machine design and use applications in biomedical engineering. I think a lot of our faculty do that as well.
So we are out of time.
Oh, sorry.
Nope, it's great. You're right on time. And yeah, we've got a few other resources going to the chat. I think Kylie put in the contact information for the ambassadors. And so if you keep having questions, reach out to them and they can either answer them or get them directed to the right folks to get you answers. Otherwise, I want to thank you all for coming to this session. I know we've got some other good ones. If you enjoyed Dr. Putlitz's mini lecture, you'll probably enjoy the ones that are coming up later today too. So make sure to head to those. But otherwise, have a great rest of your day, and hopefully we'll see you here at CSU and MEC shortly.
Thank you, everybody. Have a great day.
Thank you.
Cheers.
Thank you.